G'day, ladies and gentlemen. This is Sarah van Genen, aka Mr. VG, and this is an absolutely gorgeous day to do mathematics. Today we are going to look at a bit more of a difficult tree diagram, but one that I can tell you, if I am setting up an exam, this is the type of tree diagram question I would ask. So let's quickly have a look at this question. And I'm going to ask you to do these two sums for me, especially there's the first question, there's the second question. So Haley plays two games directly after one another. You can read through the rest, do the sum yourself, and then when you're done, you can hit the play button again on the video, and then you look at the rest of this, of the sum, how I approach it. So when I look at a sum like this, the first question that I want to ask myself is, what of the three tools that I've got, which of the three tools am I going to use? Am I going to use a tree diagram, a Venn diagram, or am I going to use a two-way contingency table? Now, since the video is about tree diagrams, it's kind of a dead giveaway, okay? But what I can actually do is I've got two games that are being played directly after one another. So I've got one event following on to another one. Therefore, I know it's going to be a tree diagram. Remember, in an exam, they don't tell you necessarily you've got to do a tree diagram. So if I look at this, the one thing about tree diagrams, ladies and gentlemen, is that there's a lot of implied mathematics, so implied knowledge. The first thing is that they say, I've got two games, game one and game two. If there is only winning and losing, which is the only two options we are going to look at, okay, winning or losing, let's look at what they say. She has a 55% chance of winning. Now, if she wins the first game, then in the second game, she could either win or lose, like I've drawn the tree diagram there. But if she loses the first game, she can still go on to the next game and win or lose. It's not always going to be like this. Just want to quickly say that. Let's say you have you've got the semi-finals, and there's only a final, not a third place playoff. Okay? If they win, then there's going to be a next match. But if they lost, there would not be a next match. Then it's out. It's done. No more second game. So you've got to kind of be careful, because a teacher can actually form a question in such a way that if the team loses, they get knocked out. Oh, okay. So please be careful and read the information given very clearly when you do a tree diagram. Don't just assume that all tree diagrams are going to look the same. Okay. But for this exercise, there's going to be a normal tree diagram, game one and game two. Now, what is the implied knowledge? The implied knowledge is she has a 55% chance of winning. Therefore, she's got a 45% chance of losing. Remember, we're not looking at draws. So just winning or losing. We call this again the complement, meaning that those two are the only options, and therefore their probabilities must add up to 100%. So on the tree diagram, I'm going to put 55% and 45% there on the tree diagram. Now let's analyze the rest of the question. If she wins the first game, meaning she's going to win, so she won the first game, that means that she ends up on the top leg. She's got a 70% chance of of winning, and therefore a 30% chance of losing. If she loses the first game, so that means she ends up on that bottom L. So that's the road she's going to walk. Then her confidence is down and she has a 40% chance of winning, which means she has a 60% chance of losing. There is my tree diagram now. Be careful of the implied knowledge of those percentages adding up to 100%. So let's look at the first question. The first question is, what is the probability that she wins both matches? So win 1 and win 2. If she wins the first one, there's a probability of that winning the first one multiplied by the probability of winning the second one. What is the probability of winning the first one? Well, that's 55%. What is the probability of winning the second one? That's then 70%, which means there's a 0.385 probability of her winning both of the matches. And this, interestingly enough, ladies and gentlemen, is the way that sports betting, sports analysis works in terms of whether someone will win. And then, of course, the bigger the chance of winning, the better your chance of making money then if they win both. But there's only a 38.5% chance of her winning both of the matches. Now let's look at the second question. The second question is now, what is the probability that she will win at least one game? So what are my options? First of all, she could win the first one and lose the second one. Or lose the first one and win the second one. Or win both of the matches. So there are my three options. So it's 1 or 2 or both. So therefore, because I'm hearing the word or, I'm going to think of adding those probabilities together. So what is the probability of the first one? The probability of winning the first one, and remember I'm using the word and, so think about multiplication, and losing the second one. Well, that's 55% times by 30%. So how do I get that again? Let's just quickly on winning the first one and then losing the second one. 55% times by 30%. Then I'm going to lose the first one and win the second one. 45%, there we go, multiplied by 40%. Or I'm winning both, which I actually got in the previous one as 0.385. So all I have to do now is add them up, and the answer is 0.73. But the beautiful thing is, ladies and gentlemen, there's always a second option in maths. I love it. I love it. I love it. If you see it, it's super simple. I could just as well say that the probability that she wins at least one game is 1 minus the probability of losing both of her matches. Because she's either going to lose both or she's going to win at least one. Okay? There's only those two. Winning at least one or losing both. Okay? Which means I can go 1 minus 45% times by 60%. That is the probability of losing the first one and then losing the second one. And this again gives me then 0.73. So there's a 73% chance of at least winning one of them. Let's say you were betting on Hayley in this case. And you would want to think, where must I put money on? Okay, now I'm not saying that betting is right at all, But think about this. I would then go and say, maybe I'm looking at the probability that she will win at least one of them, because there's a 73% chance of that happening. Ladies and gents, I hope that you are understanding tree diagrams. You need to go and practice, because tree diagrams are not easy. There's a lot of implied knowledge. But walk the roads like I did when I set it up. I did the 2 events, outcome of the first one. Then I look, but what if I happen to have to walk the top road? What about the middle? What about the bottom road? It's all about just talking yourself through the different options. And it helps to just think, what could possibly happen? And once you've got what could possibly happen, then you draw your tree diagram with that. I'm hoping you're getting this, ladies and gentlemen. You need to now go and practice it. Go and download the worksheets, try it, and have a beautiful rest of your day. This is Mr. VG signing out. Please tune in to our next video where we are going to look at practicing Venn diagrams. Keep well, ladies and gents. Cheers.